Thank you so much. My name is Marissa Hight, and I am presenting on my Capstone research Change of Heart Virtual Embryonic 3D Heart Model with Interchangeable Conotruncal Septa promotes clinically oriented learning. And my email will be at the bottom of every slide if anybody has any questions or would like to contact me afterward. I want to start this project first by thanking my mentor, Dr. Lee, as well as my capstone chair, Dr. Salcedo, and Nicholas Jacobson, my third committee member, as well as Dr. Jennifer Stratford, Noah Lepic, the Modern Human Anatomy program, and all of the medical students that helped me with this study and in participating in it. This entire project is actually based on the fact that embryology is extremely difficult to understand due to the 4D or spatiotemporal changes. So 4D meaning movement, folding, changing over time. And it's especially difficult in organ development, this one focusing in on heart development, being so that the heart actually starts initially as a single tube that has to fold up on itself. And then in order to create the typical 4 chambers that you would see in a heart, it actually has to septate or create walls between them. And so this project is focusing specifically on a conotruncal septum, which is the septum that actually separates the ventricles as well as starts the framework for the aorta and the pulmonary artery. And this is actually this teeny little area right here. And this area has to take a perfect 180-degree turn in order to properly form all of these structures. And so therefore, it's extremely important in congenital heart disease, as this septum, if it doesn't form properly, can lead to a lot of different clinical cases that will affect the person's life. And these are typically when students are learning about this process, they would see these 2D images. You can see that they're a little bit further developed, already past their embryonic stage, as well as all of the structures are in place with that congenital defect. And so there are actually very few embryonic heart models in general, and even fewer models that focus specifically, embryonic models, and even fewer that are heart models, and no models that I could find that were focusing specifically on an interchangeable septum, and that conotruncal septum in particular. So therefore, the aim of this project was to create a 3D embryonic virtual heart, or the EVH is what we called it, resource with these septa variations, as well as to assess the educational impact, perception, and confidence of the first-year medical students that interacted with this model. And so the hypothesis was that an EVH interaction will increase learning outcomes on embryonic heart development, or EHD, and to be positively perceived by those same students. So in designing of this project, the EVH was designed to have interchangeable septa variations from the actually week 4 of embryonic development. And so this is what the model looked like. It's a little bit goofy looking, but this is what it would be at this stage. And it's as if you took and you coronally sectioned it, and then were to point out the developing right atrium, developing left atrium, right ventricle, and left ventricle, all in those developing states. And then the blue section is actually that conotruncal septum. And it's designed so that way you can see that there is a pulmonary artery coming up over the top and the aorta going in and underneath. And so the clinical conditions that we focused on were some very prevalent ones that can occur, such as transposition of the great vessels, where you can see that this septum didn't turn at all, and how the outflow into those, which would be aorta and pulmonary artery, are messed up, as well as an interventricular septal defect to show a congenital defect where there's a lesion, and then to focus specifically on tetralogy of Fallot, which is, for example, showing the pulmonary stenosis that occurs in that case. And so as you can see in comparison to the images students would typically look at, this is a 3D model. They're not even sitting at the same stage of development, as these are significantly further back in development than these images would be as they're seeing. So the design of the study was a randomized single-blind study with the first-year medical students at CU Anschutz. And as a part of their flipped classroom environment due to the COVID-19 pandemic, the students were required to watch a pre-recorded lecture and to take a pretest prior to every active learning session that they were a part of. And so in this case, when they showed up for the synchronous virtual class, they were randomized into 2 groups, the first group being the control group that interacted with a model of different embryonic origin, but with similar questions and topics, and then the experimental group, which interacted specifically with that EVH resource. And so when they're interacting with the resource, they typically would be this from home, and then being able to be into breakout sessions or groups where they're able to identify some of the anatomy, as well as talk through the clinical presentation, and to take it a step further and determine how the blood outflow might have been changed in any way because of this clinical presentation. So after interacting with the resource for about 15 minutes, each student was required to take a post-test and survey. This post-test focusing in on questions that were testing specifically their learning for embryonic heart development. We were able to get a couple of different types of analysis, such as a two-way ANOVA, survey analytics, as well as thematic analysis from the open-ended questions. And so what we found out was that, unfortunately, there was no statistical difference from experimental to control group on specifically that EVH questions. There was a slight increase from pre-quiz to post-quiz, but not enough to show any significance. However, on the survey analysis, the students were able to rate themselves using a Likert scale in order to assess how helpful the model was or the resource was in understanding embryonic heart development. And they actually rated themselves to be pretty high, with a 4.6, saying that they are both between agree and strongly agree that it was helpful in understanding heart development, as well as when asked how they felt it helped in them understanding those 4D changes that the heart underwent, they rated themselves even higher, getting closer to that strongly agree and saying that helped them understand those spatial changes. However, when the students were asked how confident they felt in embryonic heart development, they averaged themselves to be about neutral or on the lower end, saying that even though they felt the resource was helpful, they didn't necessarily feel confident in that subject yet. And this can be seen specifically in the thematic analysis too. This is open-ended questions students are able to leave, and some strengths that they're able to pinpoint were that they felt it increased their understanding in embryonic heart development, as well as they love being able to see the structures, being able to see them, especially at that stage, and as well as they felt there was a need for a model in this form because it was so difficult. And this can be seen by a student specifically quoting that they appreciated the 3D model because it was hard for them to visualize those structures initially. And so some areas of improvement that were also seen in these open-ended questions or answers were they wanted more information. Any student's going to want to know more. They want to move more, beat, change, actually see it folding, whatever it may be, as well as the interface had a couple things to revise and to change. And then the time constraint, that 15 minutes they felt was just not enough time. And this can be seen by a student that specifically said there was very limited time to interact with the resource. And so they didn't feel they could adequately evaluate it at the time of taking that survey after 15 minutes. So in conclusion, the EVH did not enhance learning outcomes or student confidence, but it was found to be high in educational value, and especially due to its demonstration of complex developmental events in 4D. As well as some limitations, or that there was just not enough time to interact with the resource in order to truly gauge it. And the students' preparedness really played into this. Because of that flipped classroom environment, students are responsible for their learning at that time. And they had a previous exam the day before, so there just wasn't enough time for them to feel like they could adequately be prepared for that session and to interact with that resource at that time. As well as there was limited questions on that pre-test and post-test. Things were changed. There's actually only 5 questions. And so if the students were to get even one question wrong, they're already sitting at 80%. So it's hard to see if there's a statistical difference when, one question versus 2 questions makes a huge difference in their score. And so some future directions of this model is I've taken into account what the students have said. So I'm trying to include a heartbeat, get that septum to be able to move and to change, as well as adding that blood flow to try to help in an app form to try to help those students gain a better understanding of how the blood flow changes specifically with each clinical condition. So I want to thank all of you guys for listening to my talk and open the floor to any questions if you may have any.
That was great, Marissa. Any questions?
How might you redesign this study to get at this question of like the students really liked the resource, but didn't show any difference in their quiz scores? What would you do to change how you study that?
I definitely think that I would love to be able to include more questions. So that way I could see if there was more of a statistical difference, as well as planning the resource at a time that may have been a little bit more advantageous to my project. So that way students may have been prepared and have been able to actually interact with it, and then as well have more questions to see if there truly was more learning before or after it.
You think like multiple days of playing with the model might be advantageous instead of just a quick session?
It could be. I think it would be harder to control for some confounds in that scenario. But I think even if they got, let's say, they were prepared for class, they got an hour with the model, and then they took the pre-quiz, that might even change it a lot too.
I noticed that they only got about 45% on the questions, sort of on average. So it looked like they must have been hard questions.
I hope not. I think it's hard to go from being like a huge unit exam to being like, all right, now I'm going to understand heart development and I'm going to understand it with all these terms and whatnot. And so I think that they, not only cognitive overload, but also it's hard when it's like, oh, I missed a question. Now I'm saying at 80. Oh, I missed 2 and I failed it. So.
All right. It looks like everybody's just giving you kudos in the chat.